Welcome to the Distance Learning Packet Week 4. We have IM2 here. These are the solutions for pages 1 and 2. You should see by the side I have Desmos here. To do these, you have to be able to graph in on Desmos. Let's first of all put in the function onto Desmos. So h of t is equal to negative t squared. Make sure you use the caret to get the exponent up there. Plus 12t plus 10. Here they're asking us to find the rate of change from year 1 to year 5. So this is year 1. Year 1 is right here at, let's just zoom in so we could get year 1. Year 1 is at 121. So the first point is 121, and the second point, the question said at year 5. Nope, that's year 6, year 4, year 5 is at 545. Yeah, at year 5. Year 5, it is at 45. All right, so here's going to be your first point. This says this is at 1 year. The height is going to be 21 inches. Here it's going to be the 5th year. It's going to be at 45 inches in height. Slope formula, we should already know. M is equal to delta y over delta x, which is just y2 minus y1 over x2 minus x1. Let's just plug in the values. Let's do the top. This is, the first ones are x1 and this is x2. In red, I'm going to make this y1 and y2. That should make sense. This is the first point, xy. This is the second point, x and y. So the top is going to be 45 minus 21. On bottom, it is 5 minus 1. Do the subtraction. You should have 24 over 4, which can be simplified to, I think, 6 over 1. So 1 year, it grows 6 inches. All right, this is the average rate of change in years for number 1. Number 2, graph and identify the x-intercept and maximum of the function. Okay, let's graph this. Y equals to negative x squared plus x plus 6. Okay, oops, it's a little bit smaller, so I'm just going to zoom in here. All right, the x-intercepts are these 2 points. Here, because these are the locations in which the graph intercepts the x-axis. The maximum is the highest point, which is going to be that one. Can't really graph that well. You should have the answer. That's basically it. I'm not going to graph it on here to save time, but here you go. I could write it for you. If you would like, your x-intercept is at the points negative 2 comma 0 and 3 comma 0. Your maximum is going to be located at 0.5 comma 6.25 based on this graph. All right, there you go. Let's do the next one. Circle the value that will create this equation true. Okay, let's graph the first equation and we're just going to match it with the second equation, okay? So the first equation that they give you is parentheses x minus 7 to the second power plus 51. So this is how the first one looks like. So where is it? Where is it? X plus, let's do f of x. See if it reappears. No. Oh, there it is. So I didn't even need that. All right. Okay. So that's how it looks like. All right. So we're going to need a second equation. X squared plus something x plus 100. So here are my answer choices. So all I'm going to do is I'm just going to plug in all the different values. All right. A x plus 100. So you see here, you don't have a, let's say, okay, perfect. So do you see here, ax? Because I do not know what a is, right? So I have this option on Desmos where I could slide it. All I'm going to do is I'm going to enter different values for it. So the first one, negative 14. Oh, that works. Look. Look. Check it out. You see how the original one is in blue? Once I put negative 14, it matches right on top of it. So negative 14 is the answer. Watch what happens if I try the other one. So I put a equals to 0. Do you see how the green is still above there? A equals to 0 doesn't work. What about when I said equal to 2, right? So that's basically plugging a 2 into that equation. Doesn't work. 14, nope. Moves it to the left. And if I put 49, no, just straightens it. So it seems like that is when a is equal to negative 14. That's right when it's on top of each other. So they're equivalent. So here you could say the answer is negative 14. Negative 14 goes into that box to make that equivalent. And number 4, let's see, the graph represents the table of values. Select which statement is true or false being given on this information here. You won't need Desmos because it's already graphed it for you. Okay, so let's see. The minimum value of f of x is greater than the minimum value of g of x. So this is very difficult to do unless you graph it, all right? So I'm just going to spend time putting these dots on this graph, okay? I'm not going to waste your time, so I'm just going to pause the video here. All right, so I just finished up graphing these points. This is the blue one. This is going to be the blue function. Graphed it on here just to get a better picture of it. Notice it's still parabola. It's bigger and it's slided to the right as well and down. All right, let's see if this is correct. So this is, the blue is basically g of x. They said it here. And the black here is going to be f of x. All right, so the minimum value of f of x is greater than the minimum value of g of x. So the minimum value of f of x is located where? Located right here. This is where f of x min is located. And where this is g of x is min. So the minimum value of f of x is greater than, is that greater than that? Yeah, that is right. That is greater than. You see how it's above here? So it is greater than. So yeah. Then they say the value of x when f of x is at its minimum. So this is its minimum. And the value of x, at this point is, let's say right here. This is x is equal to negative 2. But they say the value of x when g of x is minimum. So this is where g of x is minimum. And what is the x value at that point? Well, the x value at that point is 1. Okay? Because look, this is its minimum. Okay? This is the x value. This is the g of x value. All right? So the value of f of x is the value of x is at minimum is less than. So this is negative 2 and this is 1. So yeah, this is correct. Yeah, look. This is negative 2, which is less than 1. So yeah, they're both true. Good. All right. So there you go. Those are all your solutions for pages 1 and 2.